All right, so today we're going to talk about some exponent rules and introduce logarithms. Um, might sound like a complicated word, but it's not really. If you know these rules already, most of them skip to 326. Okay, so we have the product rule. Now, the product rule is pretty straightforward. I would hope that you guys at least know these three, off the top of your head, hopefully. But if not, let's just look at some examples. So let's say I have 5 squared times 5 to the third. You would end up with 5 to the 2 plus 3, which is 5 to the fifth power. If I have 5 to the fourth divided by 5, just 5 to the first power, it would be 5 to the 4 minus 1, and you would get 5 to the third. And then the power rule, if we had 5 to the third power, and then that being raised to the third power again, this is basically saying we're taking 5 to the third and multiplying it by itself 3 times. Well, now this looks just like the product rule. So we multiply powers, we add the exponents. So this would be 5 to the 3 plus 3 plus 3, which is just 5 to the ninth. So those three hopefully have down packed. Power of a product rule, similar kind of situation. Let's say we have 3b to the second power. Anything to the second power, you just write it out twice. So we have 3 times 3, or 3 squared, and b times b, which is b squared. So this exponent distributes to both terms. This does not work when there's a plus or minus in between these terms. So you only distribute when it's a single term in the parentheses. Power of a fraction rule, similar concept. Let's say let's go with 2/3 to the third power. Anything to the third power, you can just write it out 3 times. Notice I have 2 times 2 times 2, or 2 to the third. 3 times 3 times 3, 3 to the third. So this exponent just distributed to the numerator and denominator. So we got those two. The zero exponent, anything raised to the 0 is equal to 1. And the negative exponent, let's say we have 10 to the negative 2. We are going to flip 10, so 1 over 10. And then we're going to make this exponent positive. So 10 squared is 100. So that's that one. All right, so now we can talk about fractional exponents. All right, so now we're dealing with fractional exponents, and we want to solve this. 2 to the 1/2. We know 2 to the 0, anything to the 0, is just 1. And we know 2 to the first power is 2. Well, 1/2 is between 0 and 1, so that means its answer should be somewhere between 1 and 2. So it's probably going to be a decimal. So we want to know what this is. 2 to the 1/2. We want to solve it. Well, what if I ask, what is 2 to the 1/2 times 2 to the 1/2? Well, when we multiply powers, we add the exponents. 1/2 plus 1/2 is 2/2, or 1. So we know this equals 2 to the first power, which is just 2. So now we have 2 to the 1/2 times 2 to the 1/2 equals 2. Again, they don't know what 2 to the 1/2 is. That's what we're trying to solve. But when we don't know what something is, we can replace it with the variable. So let's call this x. And because this is the same thing, we can call this x as well. So x times x, whatever those numbers are, they equal 2. This becomes something we know how to solve. So x times x is x squared equals 2, and then we want to solve this. So to get rid of the square, we use the inverse operation, which is square root, and we get x equals square root of 2. But what was x? X was 2 to the 1/2, and x was square root of 2. So if x equals x equals this, and x equals this, these two things should be the same. So 2 to the 1/2 is equal to the square root of 2. So we solved that problem. And we're going to look at some more examples with this in the next slide. All right, so we're going to try these 4 practice problems. So we have 4 to the 1/2 power, and we're going to use these formulas this time. So we're given all of these values in rational exponent form. We want to turn them into radical form. So my first problem, 4 to the 1/2, a is 4, x is 1, y is 2. So you can just, we said y was 2, so the 2 goes here, a was 4, and x is 1. Whatever number is, whatever this y is, it's the root. So if it's 2, it's a square root, 3, it's a cube root, 4, it's a fourth root, so on and so forth. So this would be the square root of 4. Well, the square root of 4 is just 2. So this equals 2. 8 to the 1/3, a is 8, x is 1, y is 3. So this would be the cube root, because the 3 is the y, of 8 to the first power. So cube root means some number times itself 3 times. And this would be 2, because 2 times 2 times 2 equals 8. So we did these two. 27 to the 2/3 power, 27 is my a, x is 2, y is 3. So if I just replace these in radical form, we get the cube root of 27 squared. Well, 27 squared is 729. So we get the cube root of 729, and this turns out to equal 9. 9 times 9 is 81. 81 times 9 is 729. And then the last one's a little tricky. We first have to get rid of that negative. And when you have a negative exponent, you flip the expression. So this is 6 over 1. We're going to make this 1 over 6 to the positive 2/5 power. Well, 6 to the 2/5, a is 6, x is 2, y is 5. So 1 is still on top. But now we have the 5th root. So some number times itself 5 times equals 6 squared, which is 36. Now, there is no whole number that when you multiply it by itself 5 times will get you 36. So we're just going to leave this one just like this. All right. So now on the next slide, we're going to talk about what a logarithm is. Okay, so logarithm, that's how it's spelled. The way that I remember it is thinking of it as the what power function. So it's some function that tells you what power something has to go to get your answer, if that makes sense. It's really the inverse of taking the exponent of something. So let's look and see, what these kind of problems will look like. So most of them will be in this form: log base b of L equals x. So let's say we have log, and log is just short for logarithm, base 3 of 9 equals x. This is asking me 3 to what power equals 9? 3 to what power equals 9? 3 to what power equals 9? Well, we know 3 squared equals 9, so x is 2. So log base 3 of 9 equals 2. All right, let's try it again. We have log base 4 of 64. Well, this is asking 4 to what power equals 64? 4 to what power equals 64? Well, 4 to the first power is 4, 4 to the second power is 16, 4 to the third power would be 64. So log base 4 of 64 equals 3. Okay, let's try one that's a little bit harder. Log base 1/2 1/8 equals x. So now we're asking ourselves 1/2 to what power equals 1/8? Well, I know 2 to the third power is 8, and 1 to the third power is 1. So if I do 1/2 to the third power, it's 1/2 times 1/2 times 1/2, which we saw earlier, which is 1/8. So this equals 3. So we're going to try this some more and look at some properties of logarithms. All right, so let's say we want to know log 10 of 1,000. And then we want to do log 10 of 10,000. We want to do log base 10 of 100,000. Well, the first one is asking 10 to what power equals 1,000. Well, if there are 3 zeros here, that means I had to multiply 10 by itself 3 times. So this is just 3. 10 times 10 times 10. 1 times 1 times 1 will give us 1. 0, 0, 0. There are 3 zeros. So it's kind of simple with tens. So here, there are 4 zeros. Here, there are 5 zeros. So whenever the base is 10, log base 10 to 100,000, a million, whatever, you can just count the zeros. And when you do not see a base, the base is 10. So when you don't see a base, the base is 10. That is very important. You will definitely need to know that. So log of 100, not log 10 of 100, log of 100, even though they're the same. But if I just ask you log of 100, you can assume that the base is 10. So that equals 2. So now let's say we want to know what log base 3 of 3 is, log base 4 of 4, and log base 273 of 273. This is asking 3 to what power equals 3. And that's just 1. 3 to the first power equals 3. Same thing here. 4 to the first power equals 4. And 273 to the first power equals 273. So when our B and L in our formula, when they're the same, x is always equal to 1. So when these two things are the same, the outcome will always be 1. So log base B of B equals 1. So these are two things that you will need to know as far as logarithms. We're going to get into more of them in the next video, but you should have enough to do the basic problems that you will have or see in ALEX. If you want extra credit, do this problem on a separate sheet of paper and send it to me. So send it to my email.